Hey, what is going on everyone? In the last video, what we did was make it so we're able to place in numbers within our Sudoku board. So we added this row down here, and if I were to click the number 7 would be placed within that cell. And we can also remove this 7 by clicking the same number twice. What I'd like to do in this video is add a solve button just below this row of numbers here, and then add the logic that's actually going to go through and solve our Sudoku board for us. So let's get started. All right, so let's close this thing down, and then we can work on actually adding that solve button just below the row of numbers that we have right here. So the first thing we're gonna do is come over to the palette. We're gonna drag a new button down onto our design, and then I'm gonna add some constraints to the left, the right, and then the bottom to all these numbers right here. I'm gonna drag this down just a little bit. Now what I'd like to do is some basic housekeeping for this button. So the first thing I usually do is come over and define a new string for our button. Let's come over to the far left panel. We could come down to our resources folder, expand that, come down to values, and we're looking for strings.xml. Double click that and the file will open up automatically for you. And within here, what I want to do is define two new strings. We're going to type in a new string tag. I'm going to give it a name of solve and then a value of solve. And then I'm going to define another string, give it a name of clear, and then a value of clear. Now, what are these two strings going to be used for? We're going to use them on our button that we just placed in. So by default, what I'd like to have displayed is solve. So this string that we defined right here, this top one, and then when the user actually clicks the button to solve its Sudoku board, it'll flip over to clear. So when the program's actually done solving the Sudoku board, the user is able to clear the Sudoku board and type in a new one. So let's come back over to our activity main.xml. And if we come over to the far right corner, we can click this split button right here to see the XML associated with our design. Then what I'd like to do is change the text of our button. So if we come down, you can find the button tag, the one that we just placed in, and we can remove this hard-coded string with @string, and then we're looking for /solve. And if we come back over to the design, you can see that the word button was replaced with the word solve. Now, I don't know about you, but the default button theme really isn't my thing. Let's come back over to the far left panel again. In our resources folder, we can right click on the Drawable folder, hover over new, and we're going to create a new Drawable resource. Now what I'm going to call this is just our solve button. So solve_btn, hit enter, and then a new XML file will be presented to you. And within here, we're just going to define a new background for our button. So we're going to create a new item, and then this item is going to contain a shape. And then I want this shape to be a rectangle. So if we type in Android, we can go :shape and then define a new rectangle for this shape. And then within our shape tag, what I want to do is define a solid fill. So let's go open and we can type in solid to define a background for our rectangle. And then within here, all we got to do is type in Android color and then set it equal to a color. Now I already have one picked out, so I'm just going to paste that in. It's this light teal looking color. And then close this tag off. Then what I'm going to do is add a stroke around our rectangle. So I could type in the stroke tag, Android color. We can define it as a color of black. Then we can type in Android width, and I'm going to give it a value of 2dp. Close this tag off. And the last thing that I like to add is a tag that'll round the corners of our rectangle. Type in the corners tag, and then type in Android radius, and I'm going to give it a radius of, let's try 100 and see what that looks like. So this should be good enough. So now that we have this new drawable resource defined, let's actually go back over to our activity main.xml and apply that drawable to the button that we just placed in. So the way we can do that is by coming just below where we defined our text and typing in Android :background. And then we're just going to reference the drawable resource file that we just created. So if you type in @drawable/ whatever you named your XML file in that drawable resource, hit enter. And then if we come over to the design, you can see it doesn't exactly match what we put in our drawable resource file. So if you are up to date with Android Studio, material design will be the default theme of most of the views that you'll place in on your design. So let's come over to the far left panel again. We could come down to our resources folder, expand values, and then expand the themes folder. What I want to do is open up both of these files in here. So let's come over to the first one. And if we take a look at this style tag, you can see there's a parent attribute. I want to change this to theme.appcompact.light.noActionBar. So I'm going to copy and paste this and paste it into the night theme one. And then if we come back over to the activity main.xml, the button mimics what we placed within our drawable resource file. Now let's make a few more changes. Let's change the width. Let's give it a value of 150 dp, or maybe not 150, that looks a little bit too big. Let's try 125. And we could change the text size by typing in Android text size. And let's give it a value of, let's try 18 SP. Make sure you're using SP because that's what Android Studio wants for its text values. 18 looks fine with me. So our button looks like it's all set up design-wise. Now let's start adding some code for our button. All right, so let's make an on-click listener for our solve button. We can do that by coming over to the main activity.java file, and then we can scroll all the way down past all the on-clicks that we created in the previous video. And then we can create another one for our solve button by typing in public void, and then I'm going to call it solve. And then within the open and closing parentheses, I'm going to type in view, and then name this parameter view. And then all we have to do is place in the code that's going to alternate between the solve text and the clear text. So to do that, what we got to do is actually grab whatever text is currently being displayed on our button. So we could do that by typing in solve button. And we haven't grabbed this from our XML file and stored it into a Java variable yet, but we'll do that in just a second. So we're going to call this button solve button, and then we're going to go dot get text, and then we have to convert that text to a string. And then we're going to see if that text equals, so we're going to go get string, and this is going to reference the string within our strings resource file. So we go get string r.string.solve. So this is going to see if the text being displayed on our solve button is the word solve, and if it is, after the user presses the button, we have to flip that over to clear. So we can go solve button, and again, we haven't defined this yet, so we go solve button.setText. And then I'm going to copy and paste what we placed in our equals method. So Control C, place it in here, but instead of solve, we're going to place in clear. So it's going to flip our text from solve to clear. But if the text isn't the solve, so we're going to go else, we're going to have to flip that text over to solve. So we're going to change this clear to solve. Then we can come up to the top in our onCreate, and we can actually grab the button that we just placed in and define that within our Java code. So we can come up here, just below where we defined our solver and Sudoku board, we can type in private button, and then I'm going to call it solve button, like what I typed out in the onClick method below. Then we can actually assign the solve button to the button that we placed within our XML by typing in solve button equals find view by ID, r.id, and I don't believe we gave it an ID yet. So if we come back over to our activity main.xml, we can come over to the far right corner, click the design tab, click on our button, and you can see our ID is defined as 10, but I'm going to change it to solve button. Hit enter and then click refractor. Then we can come back over to the main activity, and then we can type in r.id.solve button, which is going to link the button in our XML to this variable in our Java code. So now all this should be good to go, and we can actually take this onClick method and assign it to the button. So we come back over to our activity main.xml, click the button again, and then scroll down just a little bit, and we're looking for the onClick slot. So this drop down right here, and all we have to do is find the solve button method that we just created. So for me, it's at the bottom. Click solve, and now this method is assigned to this button right here. So anytime it's pressed, it'll flip its text from solve to clear or from clear to solve. So then what we can do to make sure that this method's actually working, let's come up to the far right, and we can click this play button to run the emulator, and we can just test our code real quick. So the app pops up, and if we click our solve button, it should flip over to clear, which it does. Then we should be able to go from clear to solve, and you can see if we keep clicking it, it's just going to keep alternating. So that looks good to me. So we can close this down and then start writing some code that'll actually solve our Sudoku board. So before we actually go ahead and start writing some code, what I'd like to do is actually explain the process behind solving the Sudoku board. So we can come over to this little blackboard, and I'm sure you know the rules by now, but just in case you don't, a number can't be placed in the same row, column, or box. So a box, like the large box, is this 3x3 square right here. So these thick lines that are subdividing it. So a 7 and a 7 could never go in the same box, and a 7 and a 7 can never go in the same row or column. So those are all illegal moves. So what we're going to need to do is create a method that I'd like to call check or something, that's going to go through and actually make sure that all the spots that were entered are valid and that the spots the computer are placing in are also valid. Then we're going to need to create another method that's actually to go through and solve the Sudoku board by placing in values. So the way we're going to have our computer actually go through and solve the Sudoku board is a brute force method that involves backtracking. Now, what is backtracking? It's a way to save computation time. So if you know anything about the minimax algorithm, there are pruning steps that you can actually use to reduce the amount of paths that you have to actually check. Now, this is going to be very similar to that. It's going to reduce the total amount of attempts that the computer's actually going to have to go through to solve the Sudoku board. So I drew this partial Sudoku board with the hopes of being able to kind of explain what backtracking is and what's going to be happening within our solve and check methods. So let's pretend that this was a given Sudoku board, or at least part of the Sudoku board given to our app. What our solve method's going to do is it's going to read this Sudoku board and place in values like it's reading a book. So it's going to go from left to right, placing in values along the way where there's empty cells, and it's going to keep going down, placing in values. Now, along the way, every time it places in a new number for a cell, it's going to run our check method. So, for example, if this was part of the Sudoku board given to our app, what our Sudoku board solver method would do would be placing in a 1 in this cell right here. Then it would run our check method to find out if 1 is a valid number for this cell. It would quickly find out that it's not a valid number because 1 is contained within this large box and it's in the same column. Then what it's going to do is bump this up by 1. So we're going to have a 2 in here, run the check method again, and it's going to find out inevitably that 2 is an invalid spot for this cell as well. So it's going to bump the 2 up to a 3. Then it's going to move on to the next cell because once it runs the check function on the 3, it's going to find out that this is a possible number that could go within this cell. So then we're going to start the whole process over again. We're going to place in a 1, finds out it's wrong, 2, 3, and then it finds out 4 is the next possible value that could go within this cell here. Then it's going to move on to the next one. Place in a 1. This one looks like it could be a 1. It's going to go on, find out 1, 2, 3, 4, 5. And then it looks like 5 is the next number that could go within this partial Sudoku board. It's going to move on to the next one. And it's going to get to the number 6, find out this is incorrect. 7 is also incorrect. 8 and 9. 8 and 9 will also be incorrect. So this is where the backtracking is going to kick in. So it's going to set this back down to an empty cell, and then it's going to go back to the previous cell and then bump this 5 up 1. So it's going to turn the 5 into a 6 and then run our check method again. And then it's going to find out, hey, 6 is also an invalid number, and it's going to continue this cycle. So 7, 8, and 9, all those didn't work. So it's going to make this back into an empty cell, go back, and it's going to bump up this number 1 to a 2. And then, as you could expect, 2's in this row, so it's going to go 2, 3, 4, and it looks like 5 is the next possible value that can go within this cell here. So it's going to continue this process, placing in 1s, 2, 3, 4, until it goes all the way down through the Sudoku board and actually solves it for us. So for the rest of this video, what I'd like to do is just create the check method. It should be fairly quick, but I want to cut it off at the check method because these videos are starting to get really long. So let's come over to our solver.java and we can actually define the check method within here. So let's come below our getEmptyBoxIndexes and we can type in private void and we're just going to call it check. Then our check is going to take in a row and a column. So we're going to type in int row, comma, int column. I'm just going to abbreviate column as COL. So within our check method, the first thing we have to do is ensure that we're not checking an empty cell. That really wouldn't make any sense, right? So we could type in if this.board, the row and column that was passed in. So whatever value comes out of there, it has to be greater than 0. Otherwise, it's an empty cell because we're defining 0 as the empty cell. So as long as it passes this initial check, we want to go through and check our horizontal, vertical, and boxes. So what we could do is type in a for loop, and then we can go for int I equals 0, and then we'll go while I is less than 9, and then we'll do a I++. And we're going to use this for loop to perform the vertical and horizontal checks on the cell that was passed into our check method. So to do that, we're going to type in if this.board, I, and then we'll pass in the column. So if that number happens to equal this.board, the row and column that was passed in, so this is our cell that we're checking, So if that is equal to a cell within the same row, and that cell, so this one right here, is not the same cell that was passed in, so as long as the I does not equal the row. Or let's flop this because that looks a little funny. So as long as the row does not equal I, so we're not checking the same cell, then if that is the case, so it comes back as finding a new cell within the same row, then we want to return false, but I think I made this void, so let's go Boolean up here. So we're going to go return false, right? So we're going to check and it's going to return a Boolean value. So if it passes all of our checks, we're just going to return true. So we can come outside this if statement and return true. All right, so this is going to be for our rows, and then we can copy and paste this if statement, and we can modify this to check our columns. So we can just flip our I, so we can type in row for where the I was, and replace column with I, and then leave this the same, and then change row to column, so we're not checking the same cell for the column. So now this is our vertical and horizontal check. What we need to do now is do our box check. So the box check is going to be a little bit more difficult than our horizontal and vertical checks, but it's still easy nonetheless. We're just going to do some integer division. So why are we doing integer division? That's because we're given a row and a column for our method, right? And we need to be able to take the row and column and convert them into these starting positions here, because we're going to perform our box check starting at each of these top left corners for each of our main boxes. So that's these 3x3 boxes here. So I'm going to call this as row 1, 2, and 3. So how are we going to do that? We could come down here and define a few variables. So we're going to go int the box row, and we're going to set that equal to whatever the row was divided by 3. And then we can do an int box column, and then set that equal to the column divided by 3. So what's happening? I can pull up the emulator again. So let's say we passed in a row and column of 0, 1, 2, and 2. So we're going to do 2 divided by 3, but it's integer division, so we're going to get a 0, right, for our row, and then we'll get a 0 for a column as well. So we know we have to start at spot 0, 0. Now let's say that we passed in a row of 5 and a column of 2 again. If we did 5 divided by 3, we should get a 1 in integer division and a 0 for our column, which would lead us to this point here. So you can see that we placed in any value within here, and we can get this top left-hand corner, and then we can use a for loop to iterate through our entire box. So let's go ahead and do that. We can create 2 nested for loops. So we can go for int r equals our box row, not our box column, our box row, times 3, and then we're going to go while r is less than our box row times 3 plus an extra box row, and then we're going to do an r plus plus, and then we're going to create a nested for loop. So we're going to type in for int c equals, and we're going to do all the same things, except we're just going to change the box row to a box column. So I'm just going to copy and paste this, and we're going to change box row to box column, and then don't forget, we're going to have to change our R to a C as well. So R to C and R to C, close off our for loop. And then here we can actually add in the logic that's going to be able to check whether or not a specific cell has another number within that box. So to do that, it's going to be very similar to our horizontal and vertical checks. We could type in if this.board, the row and column from our for loop, equals this.board, the row and column that was passed into our method. And don't forget, we have to make sure we're not checking the same cell. So we could go and the row does not equal R and the column does not equal C. So if that's the case, it finds a number that is also the cell that we're checking. We need to return false. So this is our box check. This is our horizontal and vertical check. And if it passes all of these, then it's going to return true, letting us know that the number that the computer placed within that cell is a potential valid number. Right as I was about to close this video, I did notice a small typo, the box row and box column. This shouldn't be plus box row, it should be +3, and box column should be another +3. So that should be it for this video. I'm cutting it off short because the previous videos have been really long. I don't know how long this one's going to come out to be, but if you enjoyed this video, don't forget to like and subscribe. Thanks for watching, and I'll see you in the next one. We're just going to pick up right where we left off here.